So we're going to talk about the problems found on the back, all right, of that page. So first off, you got to change it 4.84 to 5.6. So remember, we did these already, so this is just the same problem with different numbers. Y equals 3/4 x plus 1, y2 equals 3/4 x minus 6. So those lines are going to be parallel. So basically, if I graph it on my coordinate axes, all right, 3/4 x plus 1 is going to look like that pretty much. And then 3/4 x minus 6 is going to be parallel. All right, now I'm doing a double reflection. So since the lines are parallel, all right, since the lines are parallel, it's going to be a translation. So a point is reflected from the second quadrant, so over here, over both lines. So we're going to end up over there, somewhere most likely, unless we're high up. All right, but that's not really going to matter. What we need to figure out is this distance. All right, we need to figure out that distance. Because to find the distance that it travels, that's an interesting one. All right. So, we're going to start there, then we're going to go to there, because that's the y-intercept of 3/4 x plus 1. All right. So that equation was y equals 3/4 x plus 1. Now remember, if it's perpendicular, the slopes are negative reciprocals. So I want to get this perpendicular line. All right. So that gives me the negative 4/3 x. Now that's also plus 1 because they share the same y-intercept. All right. And remember, this one is y equals 3/4 x minus 6. So to find the point of intersection from last year, all right, we're going to take those two and find the point of intersection using systems. When they're both solved for y, we can set them equal to each other and solve. So negative 4/3 x plus 1 equals 3/4 x minus 6. If we don't like fractions, we can multiply both sides by 12. When we do, we end up with negative 16x plus 12 equals 9x minus 72. I'm going to add 72 to both sides, add 16x to both sides. I get 25x equals 84. And when I divide it, I get a decimal. 3 and 9/25 is 3.36. To get the y coordinate, I just plug it back in. I plug it back in, y equals, and you can plug it into either one of these. It's not going to matter. Y ends up being negative 3.48. All right. So now I'm finding the distance from 0, 1 to 3.36, negative 3.48. Now notice this said to round, although you're not going to actually have to. Maybe it comes out to an exact decimal, but in case it doesn't, we're finding the distance from 0 to 3.36. So whether we use distance formula or Pythagorean theorem, that would be 3.36 squared. From 1 to negative 3.8 is 4.48, so 4.48 squared. When I square those and add them, I get 31.36, and the square root of 31.36 is 5.6. All right, now, so that's what you end up with that one. For the second one, for the second problem, it says given point at the origin, A, B negative 7, 0, and C negative 6, 6. So when I graph it out, there's A, the origin. B, negative 70. C, negative 66. Yeah, I gotta make a lesson for some challenge problems. What's up?
I don't want to see you recording.
Okay. Do you want me to come by and see you?
That was just a funny little thing.
Okay. I'll be by. All right. So basically what we want to do, these are the lines. They say we start at M, negative 3, negative 2. All right. And I'm going to reflect that, it says, over lines. So I reflect it here, and I reflect it there. Now these lines aren't parallel, so you need to get a rotation. When they're not parallel lines, they're a rotation. All right, and remember the amount of travels is double the angle between them, so I have to get that angle. All right, which is angle A. They give me that this angle is 54.5. All right, and now once again, I'm going to use either distance formula or Pythagorean theorem to get the side lengths. All right, since they give me the 54.5, I figure out the distance from 0, 0 to negative 70. That's 7. All right. I do the same thing over here since I'm trying to find x. So I'm going to go from negative 7 to negative 6, which is 1. So 1 squared plus 6 squared, because from 0 to 6 is 6. That gives me square root of 37. So now I'm going to set it up using law of sines. The sine of that angle, 54.5, over the opposite side, which is 7, equals the sine of angle A, over its opposite side, which is the square root of 37. All right, I'm going to multiply the sine of 54.5 times the square root of 37, divide that by 7. So we'll write that out for you. That comes out to be 0.7074. All right, now remember we're going to go to a calculator, hit second sine, 0.7074. And that gives us angle A of approximately 45 degrees. What a nice number that is. So if this is 45 degrees, remember the amount of travels is that times 2, which gives me my final answer. All right. So that's how you do those. Best of luck. You've seen them before. You have them in your notes, and now you have this video if you'd like to.